All right, so now we get to talk about a shortcut that helps us evaluate some limits. We can't use it all the time. For some limits, it's going to make the process a lot simpler, but we do have to know a lot about derivatives in order to use it. So this is called L'Hopital's rule. All right, the L and the H is always kind of a weird thing, but L'Hopital's rule. All right, and we'll break it down into two different parts. All right, so what does this rule say? It says, suppose the limit of your top function, all right, this is what we're going to end up evaluating here. All right, we're trying to find the limit of this fraction. If the limit of the top function is 0 and the limit of the bottom function is 0, then instead of evaluating the limit of these original functions, we can actually do the exact same limit, but we use the derivative functions instead. All right, so this L'Hopital's rule is going to break down the different functions into smaller pieces. All right, derivatives normally make things kind of simpler, and hopefully the new limit works out. All right, so there's going to be kind of two steps to L'Hopital's rule. The first thing you do is you plug in your thing you're trying to find the limit of. All right, if that gives you 0 divided by 0, then you can use L'Hopital's rule, take the derivatives, and then try to re-plug in that number. All right, so now let's do some examples to kind of see what I mean. All right, so evaluate the following limit. All right, if we were doing this with a graph or algebraically, that'd be kind of its own thing. But now what happens if I try to plug in 0 into 1 minus cosine of x? I'm going to get 1 minus cosine of 0. All right, cosine of 0 is 1, and I get 0. If I try to plug in 0 on the bottom, well, the x just becomes 0. So if I try to plug in 0, I get 0 divided by 0. And that's the clue that I can use this new thing called L'Hopital's rule. All right, so for L'Hopital's rule, I find the derivative of the top, which I'll just call f prime of x. At the derivative of the top, the 1's going to go away because it's a constant. And if we think about our kind of trigonometry wheel, the derivative of negative cosine is going to be positive sine. And we know the derivative of the bottom of this function, derivative of x, is just 1. So L'Hopital's rule, instead of doing this complicated limit that doesn't work because I can't plug in 0, says I can just take the limit. All right, the exact same limit as before, but now I'm looking at a new function. The derivative of the top is sine of x. The bottom is 1. And now I do the same thing. I try to plug in 0 and see what happens. Well, if I plug in 0 into sine, I get 0. So this is going to be 0 divided by 1, and my final answer is 0. All right, so this shortcut allows me to skip doing a bunch of algebraic process to simplify this expression. Instead, I just do a bunch of derivatives instead. But taking derivatives, we've done a lot. All right, makes this problem kind of 2 steps instead of doing all this algebra work and trying to manipulate and cancel things out. All right, so that's one example. Let's do one more. All right, again, we're going to evaluate this limit. We're trying to figure out what happens to this function when we plug in 0. Well, if we plug in 0 into the top, I get sine of 0 minus 0. 0 minus 0 is 0. All right, so if I try to plug in 0 on the top, I get 0. If I try to plug in 0 on the bottom, I also get 0. So again, when you get that 0 divided by 0, that means you can use L'Hopital's rule. All right, L'Hopital's rule says you're going to take the derivative of the top. It's going to be cosine of x minus 1. Derivative of the bottom is 2x. All right, so now this limit is equal to the same limit, but instead now I'm using these derivatives, cosine of x minus 1 over 2x. All right, and now again, we try to plug in 0. If I plug in 0 on the top, cosine of 0 minus 1. Well, cosine of 0 is 1, and I get 0. Plug in 0 on the bottom, 2 times 0 is 0. All right, so in this case, I'm not done. I actually got another 0 and another 0 on the top and bottom. All right, so there's a 0 on the top and bottom again. What do? I do L'Hopital's rule. So I do the derivative of the top. It's going to be negative sine of x. The derivative of the bottom is going to be just 2. So now this limit becomes, again, the same limit part. We don't change the fact that we're going to 0. But now I use these two derivatives in its place. And if now I can just plug in 0. Sine of 0 is 0. And I get 0 as my answer. All right, so I don't want you to think that you always get 0 as your answer. It just happened to happen for these two examples. But again, L'Hopital's rule, if you're looking at a limit and it looks confusing, all right, and there's a fraction, all right, well, if you try to plug in your value and you get 0 divided by 0, which we did here, all right, that means you use L'Hopital's rule. And you can see in this example, sometimes you have to do it multiple times. Basically, you're just breaking down these equations until it works where you can actually plug in that number and get your answer. All right, so this is one shortcut we have to kind of work around doing a lot of algebra in order to find a limit.